This is the first video to section 3.7. In this section, we'll be covering inverse functions. The notation for an inverse function looks something like this. That is not an exponent, that is just the symbol for an inverse function. Sometimes it might be written like this as well. The idea behind an inverse function is to find the input that was used by a function to produce a given output. Let's remember a couple things before we move on. A function is called one-to-one if every output has exactly one input. You might remember the horizontal line test from earlier in chapter 3. If any horizontal line would only intersect the graph of a function at most once, then the function is one-to-one. So in other words, if you have a horizontal line, you only want that horizontal line to touch the function in one place at most, no more than one. So as we move along with inverse functions, let's remember not every function will have an inverse. In order to have an inverse, the function must be one-to-one. So in our first example, we're asked to determine whether or not each function has an inverse. Our function here is a line given in slope-intercept form, so we would likely have some type of graph that looks like this with a slope of 2, and you would check to see, does this pass the horizontal line test? Is this a one-to-one function? Yes. The horizontal lines only touch our function in one place and not more. So this is one-to-one, which means that it will also have an inverse. In number 2, we'll notice that this is the graph of a parabola, which will look something like this, and we might want to see if we can use the horizontal line test here. And when we do, no, this function violates our horizontal line test. This is not one-to-one, which means this function will not have an inverse. Let's look at number 3. If we were to draw a horizontal line through this, would it touch the graph in more than one place? Yes, it does. Therefore, this is not a one-to-one function. It will have no inverse. If we take a look at the function in number 4, let's try the horizontal line test through this function. And no matter where we draw that horizontal line, it will touch the graph in no more than one place. So this is a one-to-one function, and it will have an inverse. If f is a one-to-one function, then its inverse, which we write like this, one that is not an exponent, this means the inverse of f, it'll show the inverse of y equals x, if and only if the f of x equals y. So you'll want to keep this in mind here. Also take a look at the inverse of the function will always equal x, or the function of the inverse will always equal x. We'll do more with that in just a little bit. Let's take a look at number 5. We're told f of 5 equals 18. And then you'll notice over here, we're asked for the inverse of 18. If f of 5 equals 18, that means when x equals 5, y equals 18. Now, for the inverse, we're going to exchange those. When x is 18, y is going to be 5. So therefore, when they ask for the inverse at 18, that will equal 5. We're also told that the inverse of 4 equals 2. and we're asked to find the f of 2. So for the inverse of 4, x equals 4 and y equals 2. This is for the inverse, remember? So that means for the function, x will equal 2 and y will equal 4. And we would write that as the f of 2 equals 4. So these would be our two answers for number 5. Taking a look at number 7, explain why f must have an inverse function. Well, that's because this function is 1-to-1. It passes the horizontal line test. For letter B, we're asked to find the f of 0 and the f of 3. So let's see, when x is 0, that means y is 3. So the f of 0 equals 3. Now, we're asked to find the f of 3. So when x equals 3, it looks like y equals about -1.5. For letter C, we're asked to find the inverse of 0. So what this means here, that for the actual function, where is y equal to 0? So we'll look for this. Where is y equal to 0? And y is equal to 0 when x equals 2. Therefore, the inverse at 0 will be 2. Let's try the inverse at -3. What this means is when y is 3, what is x? So let's follow this on our graph. When y is 3, what is x? X is 0. And that concludes the first video of section 3.7.